Good morning. Good morning, everybody. Today we will discuss about the degree of freedom. What is the definition of degree of freedom? Definition of degree of freedom. Minimum number of variables. Minimum number of variables to define the state of the system. To define the state of the system. The minimum variables to define the state of the system is called the degree of freedom. Minimum number of variables to define the state of the system is called the degree of freedom. Okay. For instance, potential energy. Potential energy expression is mgh. So, for potential energy, mass is constant and acceleration due to gravity is constant. So, it only depends upon height. It only depends upon height. So, in case of potential energy, the minimum number of variable is 1, that is height. So the degree of freedom F is equal to 1 here. Similarly, let's take another example, ideal gas equation. Ideal gas equation PV equal to nRT. PV equal to nRT. Here P is the pressure of the gas, V is the volume of the gas, N is the number of moles present in the gas, R is the universal gas constant. So two things. One is number of moles and R is the universal gas constant. Universal gas constant. So here two things are fixed. So there are three variables: pressure, volume and temperature. Pressure, volume and temperature. But if we know the value of pressure and volume, by putting these two values, pressure and volume, in the ideal gas equation, we can get the temperature. Similarly, if we know the value of volume and temperature, we can get it from ideal gas equation, the remaining pressure. So though in the ideal gas equations there are three variables are present, pressure, volume and temperature, but if we know the data about the two variables, then by putting these data in ideal gas equation, we can get the third variable. So here we will write the degree of freedom F equal to 2. Why 2? Because the very definition says minimum number of variables to define the state of the system. So we are dependent upon two variables in ideal gas equation. So here the degree of freedom will be 2. For instance, take the Gay-Lussac's law where pressure is directly proportional to the temperature. So I can write P by T equal to constant. Here there are two variables. So if I know the data about one variable, for instance pressure, I can get the temperature here. So for these equations, Gay-Lussac's law, the degree of freedom F equal to 1. The degree of freedom F equal to 1. So this is the concept. Degree of freedom is the number of variable to define the state of the system. Now we'll use this concept in different phase diagram. For instance, here ice is kept, so in the beaker some ice are kept, water is present in solid state. So what should be the degree of freedom here? So you can put the formula F equal to C minus P plus 2. This is Gibbs phase rule. Gibbs phase rule. Here a component is what? Here water is present, so we can write in the place of component C equal to 1, and phase water is present in the form of solid only solid state is present. So in place of phase I will put 1, so plus 2, so cancel 2. So what I get here, degree of freedom is 2, degree of freedom is 2, that is bivariant, so the condition is when phase become 1, then f become 2, let's take another example. Suppose in this case, if the beaker is present, in the beaker some ice piece are present and along with some waters are present in liquid state. So in the beaker water is in two form, one is solid and other is liquid. So if we calculate the degree of freedom f equal to c minus p plus 2, in the place of component I will put 1 because here water is present in phase 2, because water is present in two forms, one is solid, other is liquid, so phase 2. So what happens? It becomes 1. So degree of freedom is here monovariant or univariant. So for this case we are dependent upon one variable. So what are the condition? When phase P become 2, F become 1. That means phase becomes 2, so degree of freedom becomes 1. Let's take another example. Here inside the beaker some ice pieces are kept, some waters are present, and I kept the one cap over the beaker and some water vapors are present. So inside the beaker three phases are present. One is solid ice, liquid water and water vapor. Solid ice, liquid water and water vapor. So what will be the phase? F equal to C minus P plus 2. So here component is obviously 1. Phase will be 3. So one is solid, other is liquid, other is vapor. So phase is 3 plus 2. So what happens? It is 0. So what happened? What you observe? That is non-variant. Here degree of freedom is not dependent on any variable. So this kind of situation is found in the case of water system. Triple point. In the case of triple point, the degree of freedom is 0. That means when water attains a triple point, it is not dependent upon any of the variables. It is achieved in a particular specific condition, 4.58 at mm of Hg and 0.0075 degrees centigrade. So what is our gist here? If phase become 3, here phase become 3, so degree of freedom becomes 0. We will correlate three things: equation 1, equation 2, equation 3. If we will correlate table 1, 2, 3, what you observe? When phase 1, degree of freedom 2. When phase become 2, degree of freedom become 1. When phase become 3, degree of freedom becomes 0. That means with the increase of phase, the degree of freedom becomes minimum. I can say phase and degree of freedoms are inversely related. This is the gist. Phase and degree of freedom are inversely related. Degree of freedom are inversely related. So what I can say, for instance, so f equal to c minus p plus 2. Suppose I want to calculate f max, that means phase will be minimum. What will be phase will be minimum means I cannot put phase equal to 0, because if I'll put phase equal to 0, that indicates that nothing is there in the system, so I can never put 0 for the phase. So minimum it should be 1. So what will happen? C, and in place of P I will put 1 plus 2. That means F max equal to C plus 1. This is one formula. F max equal to C plus 1. Similarly, if I will calculate F equal to C minus P plus 2, I will bring P here, so C minus F plus 2. Now I want to calculate P max. P max. So P max equal to C minus F plus 2. So if I will calculate P max, then I want to minimize the degree of freedom. So in this case, what will be the degree of freedom? Freedom obviously it will be 0, because you know in the case of triple point of water, degree of freedom is 0. So degree of freedom is 0 is possible. So because here we are writing P max, we have to maximize the phase. That means we have to minimize the degree of freedom. So it will be 0. So we will write P max equal to C minus 0 plus 2. C 0. So what will be the condition? So P max equal to C plus 2. C plus 2. So two formula we have derived here. One is for F max equal to C plus 1, and P max equal to C plus 2. Again I am repeating this two formula. For F max it will be C plus 1, and for P max it will be C plus 2. Okay.